Let's do another word problem. A ship is traveling with a path and magnitude represented by this vector, and the current is flowing with this vector, and each vector represents an hourly rate of movement. We're going to write the vector that represents where the boat is at the end of 1 hour. And we could do this on a graph as well. We'll do the first one on a graph. So here's my boat, and it's going 6, -4. So there's my boat. And my boat is going in this direction with this magnitude. That's the handy thing about vectors. There we go, this direction, this magnitude. And the current is flowing with the vector of, from here, -1, 2. So there we go. So my final answer is there, wherever that is. So let's just find out where that is. And you don't have to draw this one, but it does help sometimes. There we go. And it is at 5, -2, which makes sense. I'll tell you why it makes sense in a second. 5, -2. So, and here's how it makes sense. 6 minus 1 is 5. -4 plus 2 is -2. So we're just adding them, basically. So we're going to do the same thing, but it's going to be for 4 hours. Well, I don't want to draw all that, and you don't want to draw all that, so let's not draw all that. But what I will do instead, just grab this pen, and we're going to sail our ship for 4 hours. So we're going to have 6, -4. We're going in that direction with that magnitude, but we're doing this for 4 hours. So this may look like 4 is less than. It's not less than, obviously. This is a vector, so this is going to be 4 times 6, 4 times -4. We also are stuck in this current for 4 hours, and that would be -1, 2. There we go. So as with any problem, we need to do multiplication before we do addition. So let's do 4 times 6, 4 times -4, 4 times -1, 4 times 2. And that brings us to 24, -16. And then 4 times -1, so -4. 4 times 2, 8. And at this point, it's going to be really easy. It's a lot like matrices in that we can just add the particular elements together. So we're going to add 24 and -4, and that gives me 20. I'm going to add -16 and 8. That gives me -8. So if we were to graph this, this is where we would end up. Okay, 1.5 hours, it's the same thing, only instead of a 4 in the front, we're going to have a 1.5. We'll have some decimals in this one, but we'll get over it. So 1.5, that would be 1.5. 1.5, oops, there's the boat, plus 1.5 times the current. There we go. And we will just work this out. Again, multiply first, so let me do 1.5 times 6, 1.5 times -4, 1.5 times -1, 1.5 times 2. 3. Whoa, it's not 3. Whoa, 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 my bad. My bad. Wow, that was way off. I did a half. I did half of 6. That's wrong. So half of 6 is 3, but 1.5 would be 6 plus that 3, so 9. So it's like itself plus half itself. So itself plus half itself would be -6. 1 times 1.5 is, well, 1.5. It is negative though. 1.5 times 2 is 3. There we go. And then we just have a few decimals, but that's all right. I would write it below, but I don't have enough room. 9 plus -1.5 is 7.5. -6 plus 3 is -3. There we go. That is where the boat ends up with its trajectory, which would also imply its magnitude. Okay, as we get into the next section, we get into basically some pretty straightforward problems that are not that hard. So it says for the first 3, use both algebraic and graphical representations. So let's do this. It won't take long. 6 plus 4. No one is surprised at that. -7 plus 8. No one is surprised at that. So whatever's about to happen, I better end up at 10-1. So we're going to draw this one. So we're going to go to 6, -7. There's the first one. And then we'll draw the second one, and it is over 4. 1, 2, 3, 4. And then up 8, which takes it here. There we go. And sure enough, it ends at 10-1. If you want to, you don't have to, you could draw the final, they call it the resultant vector, but we're going to put it there. All right, this next one is 3, negative 3, 2. So final answer, which we could go ahead and get, would not be that hard. So 3 times negative 3, 3 times 2, there you go. And what I really could do is just draw this one 3 times. So let's do it. Negative 3, 2. There's the first one. And then from there we go negative 3, 2. There's the second one. And then we're going to go negative 3, 2. And there's the third one. That's it. And sure enough, it ends at negative 9, 6. Okay, the next one I will graph, and I will do it by hand. I'm going to graph it first, actually. So let's graph this one first. Negative 6, 5. Negative 6, 5. We all know how to graph lines. So here we go. There's your first one. Okay, but now I have 2 of these. So I'm going to draw one, then I'm going to draw another one. So 3, negative 4. So over 3, down 4. There's my first one. And then over 3 more. 1, 2, 3. And then down 4. There's my second one. And it ends right there, which is at 0, negative 3.